when we were at NAB, one of the things we started talking about was the fact that we were looking to do more cloud production. We're using Vector for extra hours on Monday nights. And, Vector has a bunch of mixing that's built in, but a lot, we know that we need an online mixer for AWS. And as I talked about those things, people kept on going, have you heard of Llama? Have you heard of Llama Audio? And I had not heard of Llama Audio, but I kept on looking around, going, because it just came up over and over and over again at NAB, and so we're really excited to have the founders of Llama Audio here, Jeroen Dieks, founder and chief product officer, and Ewan Cameron, who is the co-founder and chief commercial officer of Llama Audio. It's good to have you guys here on the show.
Thank you very much.
Good to be here. Thanks very much.
Tell us a little bit about how did you decide to go do, how long has Llama Audio been out?
Okay, so first of all, the key question we have to answer is why are we called Llama? So Llama stands.
I was going to get to that. I was going to get to
exactly. I've spoiled your.
But I guess we'll get it out of the way. We'll get it out of the way. Why is it Llama Audio?
So it's lean and mean audio. So that's nice and easy to remember. So the origin story starts with this guy here, Jeroen Dieks, maybe far away.
Yeah, so I'm actually a broadcast engineer by trade. So I've been working in audio production since 2005 or 6. And basically I've done a lot of mixing in sports and reality mainly, funnily enough. But in sports, especially in Europe, there are a lot of shows where you have just international sound and a couple of commentators. And I thought, why wouldn't you be able to automate it? Basically, that's what we built. And that's the origin of the company. So since 2020, Eurosport is using that live. We've co-developed it with Eurosport. And since then, we've developed some other tools. And this is where your story about the cloud mixing comes in. And well, I guess we'll walk through those in a bit.
Yeah, absolutely. And so, you developed it in 2020, is that right?
Yeah, so we actually started with the initial idea in 2017. And then with POCs and doing some things, trying some things. And in 2020, the product actually went live and we started the company and all these things.
If you're building something for online mixing, 2020 was a good year to do that, right? I mean, there was a lot of people looking, for some solutions.
It's very interesting as well, though, because I guess a lot of the audience coming from the States, one of the challenges that Eurosports has is that not only do they have a lot of simultaneous sports going on at one time, but they also support it in 27 different languages. Right. So you can imagine that when you've got something like the Olympics as well, the number of mixes that you need to be able to do is incredible.
And oftentimes those mixes aren't even just in stereo or in mono; they're in 5.1 or 5.
To be fair, now Europe is slightly behind the States in that respect. So at the moment, everything is only stereo. But
how cute!
How cute, exactly.
Well, so no, they tried moving to 5.1 some time ago, but it was too expensive to do it in 26 languages. And I think at this point they are actually working on moving to 5.1 again.
Yeah. And I hear with the languages it is a real issue. I did a 514 and we had 6 languages, and that just 6 languages got us to 37 tracks of audio because pulling in and out to make that work.
Imagine now 27 languages.
And they do it all kind of discrete. So every mix is all channels.
Yeah.
So, and you have a couple different products. You have Connect, you have Mix, you have the Auto Mixer. So how did you start which ones came first?
So Automix came first, and then as part of those conversations with a lot of big broadcasters, a couple of things they were asking us for. First of all, they were struggling with the audio connectivity piece, trying to convert from different protocols. And obviously the whole question about how do you get audio in and out of the cloud was also one of the big challenges as well. And then the other key thing a lot of broadcasters were asking us for is, look, to be frank, we're moving everything over to software, but we're still using these hardware mixers. And what we really ideally want to have is the same tools and the same level of functionality that we have in those hardware mixers in a pure software form. And I think the challenge is obviously a lot of the big companies out there do not want to take over the business from their existing hardware business. Whereas from our side, obviously, as a smaller startup company, we're quite eager to take that business in pure software.
Manufacturing is scary. Like when people talk about building physical products, you're just like, whoa,
stock
that's like,
and availability and all these horrible things you have to think about.
Yeah, AKM fires. Just the digital audio converters becomes a big deal. The now and then Connect is basically, it looks like a nodal compositor, like a nodal routing system, which is pretty exciting. Anytime I see nodes, I come from compositing for video compositing. Every time I see nodes, I'm like, oh,
looks familiar.
I'm home. So anyway, so can you show us a little bit about? Can you show us Mix and show us how it works?
Yeah, so maybe it's good to start with Connect actually, because Connect is how things get into the system. So Connect is indeed a node-based system, like you said. But the thing that makes Connect different from other products, I guess, is that Connect itself is actually a virtual sound card. So if I can show you quickly, if I go to Mix and I go to the audio devices, you'll see that we are actually using the Lama ASIO driver. And because it is the Lama ASIO driver, Connect will recognize it. So you can see I can actually add Mix, and we have also set up Reaper. So I can add Mix and I can add Reaper. And at this point, I can freely route audio between the programs. So this is actually how Connect started.
And why would you use Reaper as well as Mix?
So I guess from our perspective, it is just to play back audio so that we can actually test it with actual.
Oh, great. Yeah, that makes sense.
Purely for example purposes. But the interesting point was a lot of bigger broadcasters were experimenting with Reaper.
Right.
And you can actually use Reaper as a mixer, but it's not really designed for that purpose. Whereas obviously what we've done is we've designed something that's actually built from the bottom up.
Yeah.
So even just simple things like you can make changes live without getting any audio glitching. You can change out ASIOs and all this wonderful stuff.
That's fantastic.
Back to you.
Yeah. So also the case where I guess Reaper does make sense is that you can record audio, right? Mm-hmm. So that's where it does make sense, and where this actual use case where you have multiple programs comes in also is if you have Ableton Live or so, for instance, to play back some underscores or some bumpers, these kind of things.
Yeah.
That's so you need another program to do these kind of things and maybe record and maybe play some sound effects, and then everything can be brought into Mix all on the same cloud instance. That's the important thing, I guess. But we created this, and then we also added other nodes, so we've got a whole list, data center. Well, also this is the important too, I guess, for now. So the NDI sender and the NDI receiver. So we actually have NDI nodes that can go up to 256 channels, which is actually something Roberto mentioned on one of these previous calls, I guess. And so the idea is that with these NDI nodes, you can actually get all the audio you want into the cloud and out of the cloud again. So that's
great. And that can be lots of different inputs. I mean, we're in the cloud, and we can use NDI to get in and out. And are you supporting some of the new Dante tools for cloud-based transport?
So anything that is an ASIO driver can be loaded into Connect, and actually multiple ASIO drivers, and actually also other types of drivers. So WDM can also be used, but of course all the professional drivers are ASIO drivers normally. And
then I noticed you had filters in there. You're able to add filters as well.
Yeah, you can add VST plugins.
Right. That's
so you can
fantastic.
make change to VST plugins as well. But I know Josh was we were just on the session beforehand with Josh, and Josh was actually talking about the whole, originally, I think even a year ago, you were talking about converting from Dante to NDI. And obviously this is something that you can very easily do.
Yeah, so for instance...
getting from one to the other, yeah, absolutely.
Exactly.
Yeah, so if I would add just very quickly as a demonstration, if I would add a device I/O, I actually get a secondary device manager, basically. So I can just go in here and then select another driver. And so in this way, you can actually add multiple device I/Os and then do format conversion between different formats.
And then you're just simply connecting one output to another input. Is that right?
Yeah. So you could, for instance, do this, and then you would have at this point. Well, at this point, because we might want to have share our system audio, we are connected to the WNM driver. But in fact, this is MADI to reroute now. But it could be anything to anything as long as you have a driver.
So we're trying to be the Swiss Army knife of audio connectivity and conversion. That's really sort of the high level idea here. And the nice thing is that everything that's happening within the graph here is not adding any additional latency. So you're not going to get those sync issues that you sometimes get with something like, what is it, ASIO for all? Or no?
Oh, you mean Jack Audio?
Jack Audio, as an example.
So Jack Audio would add buffers every time you go in and out of nodes. And we actually have, basically within one buffer callback, as it's called, we actually do the whole graph. So
and is that, are you doing that because you're does everything run at low latency? I mean, because some VST plugins would add buffer, wouldn't they?
Yeah, of course. So input and output that we don't add any latency, but if the plugin itself adds latency, and also, of course, if you do sample rate conversion and these kind of things, it would add latency.
But otherwise, you're basically concatenating those nodes. Is that right? You're figuring out the entire calculation from one side of the path to the other, rather than doing it at each node. Is that how you're saving that time?
Yeah, exactly. So we basically monitor when a node has written its output, and then immediately we give it to the next. Exactly like that. Yeah.
Yeah. No, that makes sense. So here you could say, okay, I've got a couple inputs coming in, and I can send it out to this device, that device. I can move them around. I can make conversions. I can say this is coming in via Dante. This is coming in via NDI. Reroute those all and set them up of how they're going to enter the mixer. So or any other device, right? It can be sent out. You could send them all out as NDI. You could reorder your NDI. Mix it with other inputs, mix it with a lot of, all those other bits and pieces.
Yeah, exactly.
And then send it out. And this can be done again on the computer, right? So this can be done on the, if you have all those things happening on one PC, it could do all that routing internally.
And just to be clear, it is Windows based at the moment, but we will be later on in the year moving also for Mac and also for Linux as well.
Oh, that's fantastic. Yeah, I wasn't sure. For us, we've been looking at it as a cloud-based thing, so the Windows made sense for us.
Yeah, absolutely. But a lot of the broadcasters are also asking about Linux now from a
so from our perspective, actually, Mac is the least.
Right.
A lot of people like it, but of course, Mac is the least important for broadcasting.
Interesting.
So it's all Linux and Windows indeed.
So this is. Go ahead.
Sorry, just one more thing I was going to mention on the Lama NDI sender and NDI receiver as well. We've worked very hard as well. We've actually introduced a buffer scheme as well, so that it's a rock solid timing, because that was one of the challenges that some people had in the past, that there was some audio drifting when it came to NDI. That's all been solved now, so it's rock solid.
That's fantastic. And then you can will this create devices on the other? Can you create a device with Connect that so it shows up as another device for other apps that are sitting on the computer? Is that possible?
No. So other apps, it's the opposite. Other apps show up as a device inside of Connect as long as they've got the ASIO driver selected.
Yeah.
That's great. That's fantastic. So this is how you reroute, connect all the IO that's out there. Then this is where you go to mix. Is that right?
Yeah, and so just very quickly, indeed. So we've also got the matrix view, just so you know that you don't have to use the node view. Some people might like this view.
I guess if people are used to using something like Dante, then that's obviously a lot more compelling.
It can be a lot faster. Like I think you're just tapping.
I find it very easy. Yeah, but there are nice little shortcuts. So maybe you can show that
just very fun. So if you make a connection while holding control, you actually get this screen, and then you can say, okay, 16 connections. Well,
that's great.
Done.
Yeah.
Now, if you build complex ones, does it route around them, or does it everything's straight?
So currently it will do this, I guess.
Yeah. No, absolutely.
So that's maybe where the grid comes in. But,
that's actually a good feature request, I guess.
We build a lot of wiring diagrams, so we try that's less of a routing thing and more of a wiring diagram thing. And then what's Graph plus Grid? That's showing you both of those at the same time.
Yeah.
And if anything that you do in the grid will represent itself in the graph and vice versa.
Yeah.
Exactly. Yeah.
So you'll see it there.
I see. There you go. It's great.
So is there any questions on the Connect piece, or should we jump straight into Mix?
Let's see here. Hold on. We made that change. I got myself a little turned around here. Let's see. Sorry. Let's see here. No, let's go ahead. Well, let's. We have one question coming in about Connect. So go ahead and let's go ask that question from Mickey. Go, Bill.
There it is. Okay, it just popped up. What's the typical nominal in to out latency? Can I ensure consistent latency across mixed sessions?
Yes. So it is literally what you select as your sound card buffer size, times 2, of course, because you have one time on the input, one time on the output. So if you have, for instance, RME or any of these brands, they support up to 32 samples. But almost no computer actually handles this. But 128 samples or so input output, it should be very doable. And we also have our own scheme, basically. So we have this thing called Lama Audio, and if you select Lama Audio, then actually the whole graph will clock itself. So it just so that you know that you don't actually need an RME or other brand sound card. You can actually use this standalone in the cloud without a sound card, and then things like NDI actually become your inputs. But then from a latency perspective, of course, then it's a little bit more difficult. So we will, of course, stay on one latency, but depending on your network, it won't be 128 samples. It will probably be 10 milliseconds or so, probably in the clouds.
Courtney?
And to maintain that latency, low latency, do you have to agree on sample rate and bit depth throughout the connect, or is
no?
It,
so we do
does it do sample rate conversion?
No, we do sample rate conversion. Yeah,
and bit depth conversion.
Yeah, exactly.
That's great. Next question.
Next one comes to us from Andrew Lipnick on the panel here in San Francisco. How much computer power do I need if I'm only using Llama as a MADI to Dante converter?
Almost none. Almost none.
Almost free.
I can probably show it. That you'll see that. So where's Connect? So let's just search Connect.
And now this is for Connect, but
here's 0. Yeah. So if you do just sample to sample conversion, it's just copying of memory. So it will not. If you do it through NDI and bridges involved, then it becomes heavier, because then you're doing transcoding and such. But as long as it's really just MADI to Dante or so, it should be almost free.
And if someone's saying I'm going to put on, and would you typically run Connect and Mix on the same computer?
Yes.
And
yes,
in that,
so just to be clear, they can run separately as separate products, but obviously the real power and the magic comes when you actually combine them together for the conversion and for the connection.
Yeah.
And we've got another
impressive, because a direct out product, this is a hardware MADI to Dante converter. Yeah. It's like, I don't know, $2,500, $3,000 just for that. Yeah. So I'm dumbfounded by how the economics of all this. It's impressive.
Thank you.
That was the idea.
Next question.
Samuel Nordvik, coming to us from Norway in this case. Is the audio being mixed on the CPU only, or can it be offloaded to other hardware?
It's CPU only.
CPU only.
And is it using GPU at all, or is it all CPU?
No, because when we started the company, actually, even Automix, which is the product that we started with, people wanted to run it on as minimal of a spec server as possible. Yeah. So we made everything run CPU only, basically.
That's great. Next question.
Actually, in audio, running things from the GPU can cause extra latency because it's basically two different devices, right? And you need to do data transfer between the two. And so from the CPU, it's actually easier.
That makes sense. Next question.
Henry Ramos, coming to us from Yonkers, New York. What do your sports clients use to ingest analog or AES audio into Llama?
Yeah, good question.
So mostly merging devices, actually. So Anubis, and they've got it's called the HAPI, I think, HAPI. And there are some other devices that, and of course they do have some Labo gear. So everything that supports Ravenna or AES67.
But just to be clear, also, we are in the process of actually tying down that we're going to be developing an AES67 node also for Connect as well, which I think.
So I think I misunderstood the question. So from the perspective of Connect, currently everybody is also using the merging driver or the RME direct out module. But we are indeed also developing our own native AES67 node.
Let's go ahead and jump into looking at Mix.
Great.
Okay, so this is mix. And I've made one channel just to very quickly already show this. So the controller actually is of course mapped to the software, and so we've got an input section on every channel with a gain, a delay, invert phase, a tone generator, a VST strip. So you can.
And what's the maximum delay?
I think 5 seconds at this point.
That's
5
great.
seconds.
But if you would need more, then we can add more.
Well, no, the question I always ask, I always do that is like, are you delaying for things like wireless mics, or are we delaying for audio, video, sync? And obviously those numbers are dramatically different. So that's what I'm always asking. But the 5 seconds is, if you've got more than 5 seconds, you've got some horrible issues going on.
It's not your problem.
Yeah.
So we've got a channel strip on each channel, and we can actually go into the details of the channel strip. And well, you see that we have a filter section with a tilt EQ also, which is not on many mixers. We've got an expander, which is also the gate basically, a compressor, an EQ, a de-esser, and a limiter. And we can also change the order, so you can make any.
So that's the order of processing.
Yeah,
from left to right.
Yeah.
And so we've got a connection section where you would just add your auxes and the inputs. So here I can add the inputs, and now this is input channel 1. So one of the things, of course, that we have that a lot of software solutions don't have is that you can create any mixer that you want. So I can just add 20 or so input channels, and you'll see 20 extra input channels.
Right.
And we can add, well, let's make a stereo bus. So now we've got a stereo bus. And let me just, for demonstration purposes, also create an aux. So the aux is also created. And then, so what makes this a broadcast mixer is, well, one of the things that make it a broadcast mixer is that we have pre-fader, post-fader, but also basically a bird beater, so mute on fader open. So for instance, if you want something going out through an aux to an intercom panel, but you want it out of your program when you open the fader, this would happen now. So it would go pre-fade to an aux, and then when you open the fader, it automatically mutes. So on the left side, we have, of course, an overview of all the channels. We can also create a group. Let me show you quickly. Let me put the group here. Just very quickly, you'll see that it actually has a VCA. So every channel we now put in the group is actually handled by the VCA. And every group has a VCA. So we have a layer view. So this is basically what other mixers also have, right? So one layer can have these channels, and the second layer can have these channels. And so you can switch between the layers. Let me quickly see if I can show you. Oh yeah. So now we're in. So the F keys of the controller are actually switching. So you'll see that F2 is now layer 2, F1 is layer 1, and if I press it again, we're back to the standard view. So that's
Great. And
so that's
yeah. And yeah, go ahead, Bill.
Oh, I put that in earlier. I was during the opening. I was interested in just kind of your design philosophy of the whole thing, and in this sense, when I see virtualization of tasks that used to be done mostly on analog equipment or at least fixed equipment, I'm always thinking, what the designer, how much did you think about adding features like the one you just discussed, where you can improve things by kind of redesigning it for the modern digital era? You know, when you do this for this function, it's going to be muted rather than open like on a regular mixer, and you have to make that happen. Did you spend a lot of time in design thinking about what you wanted to add that might be outside the norm versus making it so normal that all the engineers can just immediately get in there and start working with it?
Yeah, so I guess this is actually where Automix and our plans for Mix Assist come in. So we started with Automix, which is really a totally different design philosophy. And there you would literally just add a mix by creating certain input channels like commentator 1, commentator 2, international sound, and then you would just have buttons for taste. And but So people like that, but people also wanted a regular mixer. So that's why we created this as the regular mixer. But we are actually going to add the Automix functionality in here. Indeed,
I guess this is the interesting thing about change and about creating something completely new, is that what we're doing here with regards to software mixing, it is a change process as well. You've got to get people comfortable with that change process. So the design philosophy for Lama Mix was, okay, yeah, we're going to try and be as smart as we can about how we can use the fact that it's software versus hardware. But at the same time, as you said, it needs to be easy enough that somebody who's used to using a hardware mixer can come along and within the space of a few minutes, they can understand the basics and get going. Yeah. And that's kind of like been the design philosophy. So, what existing broadcast desks currently have.
And how constrained do you feel in that channel world? So like, for instance, I think a parallel in compositing, again, I come from the video side of things, is that, we have a layer-based world, which is like After Effects and so on and so forth. And we do this layer-based. But once you go into nodes, you kind of find the layer-based to be pretty constricting. Like, it's kind of like I can't believe we're here. And so with mixing, like when I saw the Connect, there's some of us that would love to see a mixer where I don't have any channel strips. I just have nodes, that are all, I just have nodes, and I attach those nodes back to controllers, and I can do anything I want with those nodes, as opposed to trying to kind of think in that kind of layered approach. Is that something you've thought about as you build this out?
Yeah, well, I think to be clear, you can actually use Connect for that purpose. You can actually build up a mix by literally just pulling together your VST plugins and actually creating your workflow that you need to.
So you could theoretically just mix the whole show inside of Connect. You could
exactly.
You want to.
Yeah.
Exactly.
It would make people it would make a traditional mixer melt down, but it would.
Yeah, well, that's the interesting point, is when we originally built Automix, we thought we're going to go out there and everyone's going to embrace us and say, great, you guys have, you finally built the answer to everything. And they were like, yeah, but have you really just got a software mixer that I can
have you thought about channel strips?
Yeah, exactly. So we were kind of like pulled back to, so I think the expression is softly, softly, catchy monkey. We have to be careful here how we transition from what effectively we hope is the past towards the future. And this is kind of like the bridging period. So just to be clear, also what Jeroen was saying as well, is that the functionality that we included within Automix, we're actually going to include that later on in the year, beginning of next year, actually in the mixer itself. And instead of calling it Automix, which, to be fair, some people really don't like the sound of because it's kind of like a scary thing, we're going to call it Mix Assist. So it's assisting you in your mixing, and it's a bridging period between the past and what we hope will be the future.
I think a lot of us are on the same page, because you do feel like you're just kind of contained by the past sometimes with the old way of thinking.
It's the joke also when you see VST audio plugins, and they're recreations of 1950s gear. It kind of makes us feel all comfortable and a little bit warm and cozy. Yeah. But
I'm definitely going to remember softly, softly, catchy monkey.
Yes.
Thank you. If we were going to give it a title for the show other than your name, that would be it. We would normally say we have a title. Let's go. We got a bunch of questions stacking up. Let's go ahead and jump into those questions again.
Mickey Makachorin, right now in Paris. What controllers do you support? What controllers do you recommend with at least 32 channels?
Okay, so it is Mackie Control. And so any Mackie controller will work. But I think the two main ones that people use these days are either the icons like we have here, that I think we can show.
No, we can't, because we're not on OBS.
Because OBS crash, sorry. Yeah, so we've got an icon, but it's the icon controller.
I can show one, baby.
Yeah, we've got the small one.
Oh, okay.
1 sec.
And how are they attached to how do you attach the hardware to the software? What's the process?
So now we're back to.
So literally, so normally you would just need to make sure that the MIDI input that is connected to the icon controller is actually also going into the mixer, and then since Mackie Control is all MIDI, everything works out of the box.
But also, I think it's interesting at this point to add what we've done there for the Connect and for the cloud mixing scenario, that you can actually add, there's a MIDI sender and a MIDI receiver actually within Connect itself.
Yeah,
I was going to ask that next. I was like, hey, can I just apply sliders to connect? Because I have to admit now it's a challenge for me to mix a whole show inside of Connect. Now that I know that it's possible.
We're up for that challenge. So if you want to do it,
we'll start sending feedback. Where's this button?
One thing that actually, so this is not released yet, but we are also working on a REST API. And so we are actually planning, or in the backend we've already got it, to share all the parameters of VSTs through the API. So you could literally just have indeed build your own mixer just using VSTs, and then through the REST API just control everything.
Yeah, because one of the things that we've been really talking about is the abstraction of taking away the direct connections to the software or the hardware and displaying them on an interface that we build. So a lot of shows that we do are repetitive. It takes a lot of, but once you figure it out, it's like go up, go down, go to this, go to that, and we kind of don't want to look at the interface anymore. What we want to do is build an interface for the operator. Now you could always open it up if you need to. Like if something happens, you open up the interface and rewire something. But when you're running the show as is, you could just sit there and just tap on an iPad or whatever and have it just, and being able to tie that, being able to build something that's arbitrary and then being able to arbitrarily connect that to interfaces.
So one thing we've been experimenting with ourselves for some shows that the Ewan is actually sometimes still doing, is so we've got this preset system. And so the other day we actually, so these presets, they can be MIDI learned. So you can just bind them to Stream Deck. And so the presets,
now you push that button and then all these things can turn on or off.
So let me just, because I actually made the same preset twice. So let me create a new preset, and you'll see. Let me just very quickly walk you through this.
Yeah.
That if I go here, everything goes there. And if I go here, everything goes here. And so, but the thing is that this is the state of the whole mixer, and we can now edit actually how it is being recalled. So we can say, okay, this preset needs to be recalled quicker, and then you'll see that it jumps up quick. And I can say, okay, this preset, so we're not recalling channel 1. So save, and then we recall it, and you'll see that channel 1 is actually staying there. And so in this way, you can basically map out your whole program, where you might want to do your dialogues manually, but everything else automated, and then just through indeed walking through the presets, do your complete show.
But even just having the crossover period being adjustable is something that isn't that common, I don't think.
No.
Well,
so you can make a very smooth transition between two things, or do it very quickly.
Yeah.
And and are you again? And you're not 5.1 yet, but you're working on that.
Yeah, we are.
No, we have a long list of broadcast customers in the States that are saying, as soon as you're there, guys, give us a call. So, yeah.
Well, and no, the reason I ask, one of the things that we have challenges with now, because immersive is coming for us, so we do a lot of immersive work, is that when I jump from one immersive camera to another, I have to change the mix for every camera. So it's an interesting puzzle.
So how I guess what you could do, but this is not the ideal situation, of course, but what you could do is create all your cameras into a group, and then the VCA is basically the level, and then you can basically spill it.
Yeah, the way we do it in like a Yamaha is we have a scene, and that scene is connected via GPIO to the switcher. But we could definitely find a way that information could all be done in software. That's really interesting. Let's go to the next question.
Next one comes to us from Samuel Nordvik in Norway, and Samuel wonders, do you have experience transporting large numbers of audio channels from ground to cloud? And if so, how do you achieve this?
Yes. So we do this with NDI actually. And so basically you would have Connect running on both ends. And on one end, you use Connect to convert all your local streams to NDI, for instance, Dante or Ravenna, all these kind of things, Madi. And then once it is NDI, you just use NDI Bridge to push it to the cloud. And actually, one other thing that we've also within NDI, but what we've been experimenting with is using VPNs and not using Bridge at all, and just push it directly over a VPN. So zero tier is one we use a lot. Use it directly to the cloud, and then you're actually not transcoding to Opus, and then the latencies can go. So we've done some tests between where we are, basically in Amsterdam and Frankfurt, AWS, and we got round trip latencies of 12 milliseconds. Or no, it was 12 milliseconds per side, so 24 in total. So 12 milliseconds to go from Amsterdam to AWS and 12 milliseconds back, which is about 300 kilometers, Frankfurt and Amsterdam.
And that's the raw IP, or is that's actually what it's taking to deliver the audio?
Yeah, that's the time that it delivers. So how we measure this is we basically had Connect running locally. We ran Reaper there, played out from Reaper, basically in the cloud, pushed it back to the local. So from Frankfurt, basically pushed it back to Amsterdam, and there recorded it again. And then you can see the time shift, and that was 24 milliseconds. So 12 milliseconds per side.
Yeah, absolutely. Next question.
Andrew Lipnick, who's here on the panel from San Francisco. Do you have matrix buses?
So matrix buses. So we have auxes and buses, and you can route everything through. So we don't have an actual matrix bus, but you can just route things to the buses and to the auxes in any way you want, and you can make as many buses and auxes as you want.
But can you feed buses to auxes or auxes to buses? Can an output feed another output?
Yeah, exactly. Yes.
Okay.
Because for you, it's just arbitrary. Like it's not.
Yeah.
There's no circuitry required.
No. So it's not the. I think it's Alan and Heath, right, that do the matrix thing. So, I think matrices are just in the back end, probably just auxes that just indeed can send to each other, and so we just have the auxes.
Next question.
Rian Smith, coming to us from Trinidad in the West Indies, says, can Lama be considered an audio DSP version of SDR, software-defined radio, like everything into everything through a single PC?
Interesting.
So I never thought about this. But yeah, so it is software defined, and you can make radio, and you can do everything in one PC. So I guess so.
This is why office hours are so much fun. I didn't think about it that way before.
Well, we started off the day asking about banjos, so I mean, it's
yeah,
There's that. I think we already answered this, but go ahead and next question.
Sure, Douglas Carmichael's back in with, would you ever think of developing a Mac OS version of your products?
Yes.
Yeah. And the second one, I think we already answered too, which was, this is less of a if and more of a when. Go to the next question.
Jeff Keithley, our friend in Texas, says, when is my coveted Linux Linux version going to be available?
Yeah. So over to you, Jeroen.
Yeah. So probably something that we haven't mentioned yet is that we're working with NDI to create a virtual sound card. But of course, since we're working with them, one of the things that they wanted was it to be available on Linux and Mac also, and for us this is a good opportunity to move everything over. So I cannot give you an exact date, but I would say this year everything should be also available on Linux and Mac.
And as you do that port, is that port something that you're really doing a custom port, like for Linux, I think, and Windows are close together, but the M1 on the Mac has an entirely different infrastructure, or potentially an entirely different infrastructure to program to, which is much more efficient if you write directly to it. So the ports become more complicated. And this is why, again, we didn't assume that a lot of us are heavy Mac users, but we're not assuming that we were going to use Llama on a Mac, because to properly port it over, it would be, a lot of rewriting to take full advantage of the M series chips. How are you approaching that?
No, so it's actually, from our point of view, so everything, just to go a little bit technical, everything that we do is C++. And so it's if your compiler is made to convert the same code to another platform, that shouldn't make a difference. And also No, but
That's not been our
Maybe
experience.
we'll get back to you on that, Alex. Ask us in a couple of months.
Yeah.
But in the audio scene, there's actually also frameworks. So we use a well-known framework to program audio applications. There are a couple of well-known frameworks for audio applications, but by now they've also matured very much on M1, and so you'll see that all the VST plugins these days are also on M1s. And it's all from the same code base. That's actually on also for Windows. Just
right.
The framework handles all the details, all the differences.
Yeah, a lot of us, I mean, that work on development on the Mac, what we've seen is just huge performance changes if we write directly to them, literally to the metal. so it's a different. I mean, it definitely works to port it, and it's can be good enough. But we definitely see we see some manufacturers when they're writing straight to the libraries that Apple builds, we end up with huge performance increases. But it seems like yours is light enough; it may not matter, for those kinds of things. Let's go to the next question.
Peter Moore is coming in from Auckland, New Zealand with this one. Whilst GPU audio is pretty much in its infancy and possibly made redundant on Mac OS with the M-series chips, regardless, what, if any, plans do you have to adopt GPU-accelerated audio in your products?
And it sounded like we answered that too a little earlier.
Yeah, we kind of touched on that before. At the moment, it's not really seen as a viable alternative for the time being.
We might use GPUs as soon as we are actually going through the AI craze, because then maybe we would need it. But for all the regular audio processing that we're doing, it's not really needed.
Also, I guess the key phrase here is real-time audio, isn't it?
Yeah.
So that's also one of the key things as well. You've got to get those latencies really low for live performance.
Yeah, so there's one company who actually proven now, I think they're called GPU Audio actually, that you can do low latency audio on GPUs. But before them, everybody would consider GPUs kind of like DSP boards. So that would add extra latency .
And if someone asks you, okay, I'm going to set something up in AWS, what size of an instance should I be looking at? What do you tell them?
Yeah, so normally we are using the Epic instances, right? The AMD ones, and so the general compute ones, and so the one that we experiment with a lot is the 2XL, which is I think 16 cores, I think, or 8 cores. I don't remember exactly, but the 2XL is the one that we experiment with the most, and that should be good enough for most things.
I guess it also depends on track count and also the amount of processing you're actually putting in each of those channels.
And if you want to run reverbs and whatnot on all your tracks, or just use the built-in mix things.
Yeah, so the actual built-in channel strips themselves is actually really, really economical. One of our founders is a guy called Jochem de Jong, who comes from a DSP. He's a DSP guru, basically.
Right.
Baby Audio and lots of other plugin companies he's designed plugins for. So it's very, very efficient if you're just using the built-in plugins. But obviously, if you want to use something exotic when it comes to VST plugins, then that can increase the load a bit as well.
No, makes sense. Next question.
That comes from our own Courtney Gooden, often here on the panel from Hollywood. Can it run on small Celeron quad-core PCs like the Mealy Quieter 4? And if so, how many channels is it limited to, or any?
It can run on smaller PCs for sure.
This is what he's talking about here, by the way. This is these little Melee.
Wow.
Yeah.
So the only thing we would have to double check is if the chip actually supports AVX, which is kind of like an instruction set.
Mm-hmm.
As long as it supports AVX, it runs on it. We would have to test for channel counts, but I'm expecting that 16 at the very least.
That's great. Next question.
Roscoe Jones, coming to us from Madison, Indiana, wonders, would you mind identifying what technologies you're working with that you consider proprietary and those that you're using that you consider non-proprietary, both in apps and signal processing, please? And are there any licensing costs inside?
So this is probably a question so for our perspective, if we need to pay for licenses. Yeah, so of course, so we are using a framework, which I just talked about, which is Juice, and that's proprietary. So we pay licenses there. Everything else, I think, is done by ourselves.
Yeah.
So there are some other libraries. So of course, we have a REST API, but there are just open source REST API libraries in C++. that are free to use, MIT licensed. But everything that you see on the UI, but also all the DSP, is actually created by ourselves.
Next question.
Dave Troutman from Edmonton, Canada is in next. I may not have caught this earlier, but do your setups get saved as project profiles?
Yeah.
So yeah, you can just create a.
How do you? I guess you save them out, and then you can just send them to somebody, right? You can just say, "Well, this is my show."
Yeah.
And I assume that's the same thing with Connect, right?
Yeah, exactly.
Yeah. And quick switching between shows, or literally.
Yeah, you can just open another project. It's in that sense, it's kind of like a DAW, of course.
Now, am I pushing you too hard to ask you to show us a little bit of how to attach something in Connect? Like, I'm very interested. I have to admit, you've got me kind of, tied into. So if I wanted to build a mix in Connect without mix,
Okay.
So let's just say.
I only say this because in a couple days, later today or tomorrow, I'm probably going to try to do this. So I'm very fascinated by it.
So this is just an example. Actually, this is a Juice example plugin that is underneath examples.
Mm-hmm.
But you could just do this, right? And then let's add some fab filter or so. So let's add an EQ.
Mm-hmm.
So you would just do this, and then you can add some more plugins, and then just go to your output. And
then how do you attach the MIDI control to the gain?
So you would need to have something that has MIDI control, and we actually have two different types of MIDI ports. So this one is the global MIDI in, which is also basically something provided by the Juice framework. Just listens to all MIDI ports, but we have our own MIDI port also. So it's the MIDI input, and so this one actually listens to a specific port. So you can just say, okay, I want to listen to this port. And then you would attach the MIDI like this. But if you want to have everything to function or respond to MIDI, then you would need to choose your VST plugins that actually support MIDI.
Well, but like if I want to control gain, for instance, through an external hardware controller, how would I do that?
Yeah, so I guess I think the Pro Q supports these kind of things where I don't know exactly because this is of course not our product, but there is a way. Yeah, here MIDI Learn. So there are multiple plugins that support MIDI Learn.
Got it. So that internal gain wouldn't have a dial to it, but you would do it in a plugin that's south of that gain there.
Yeah, exactly. And then you would just route your MIDI, and then you would just learn all the parameters.
That's great. Yeah.
I think something to mention is that Connect itself is basically our. So the connectivity products, but we keep adding standards like we want to add SRT and all these kind of things, and then the idea is that at some point we also add our own VST plugins so that you can actually do whatever you want. So we can actually create a lot more products on top of Connect.
So I think this is also a good point at this time to say something as well, which is everything that you see here has been made and designed with our customers giving the feedback. So if you guys have got good, stupid ideas, we want to know what the stupid ideas are.
Well, I mean, like
stupid ideas equals products, basically. So that's what we want. We want that thing.
What I love about this, so the thing that I'm very excited about the Connect part. I know that the mixer part I'm very excited about too, but I'm not a traditional mixer. I'm a traditional I'm a nodal compositor, and so I think about things in nodes. Yep. And I think that it might be interesting for you to get input from somebody who's used to using this in very complex ways.
Absolutely, yeah.
Because the problem that we've seen in the past is that a lot of people who come from audio continue to want to find structure, so they don't let you do what you're doing here, which is that they constantly want to create rows. Like, again, I think it's just they're used to seeing rows, and they just constantly are creating rows. And for me, it's like I just want to lay things out the way I want, because a lot of times in a composite, like let's say I'm compositing someone's arm, that arm is just brought over. These are all these nodes that do that, and I can just go over to this little village that is the hand, and I can work on that, and then I have something else for the general, and then that all feeds back together. And the issue is that so what we do is we have a lot of times we have inputs. So like that gain input would just have a controller. Every aspect that's every slider that's inside of that gain plugin if it was a compositing tool would have it would have a little node that was at the top, and I can just connect it. Now that node that goes in could be a MIDI controller, but it could also be the math of when this, you could have a math node that says, take this node and multiply it to this node and then bring it in and have it control the gain. I don't know why you would do that, but you end up with this kind of like, all those nodes don't really care. And sometimes you have a node that controls like what the range is of that, of rearranging it and so on and so forth. But the point is that every node has all of anything that you can adjust has these little hooks to it, that we can just draw into it. And how we do the math to get there is completely opened. And what you end up with is being able to build things that you could never imagine. Like, you build very complex node networks that you couldn't do. And like when you're used to a nodal compositor, you can look at the layers and there's just things you could never do in layers. Like you couldn't get there. So
yeah, so I guess from a music perspective, if we just go since you started there also, that's basically the idea of modular synths indeed, and
right.
So it's called the Reactor, right? I think from Native Instruments.
Mm-hmm.
That's basically this kind of idea, and there's Max MSP. But they're really from the synthesizer point of view, and we are, of course, more from we've got audio and we need to connect things. But I guess at some point it would make sense to have some control data also here floating around other than MIDI.
Yeah, I mean, it's just and then it's just again for us we want to be able, and then I know that you're working with REST and so on and so forth, but being able to have things where again we want to kind of connect those pieces together. So it's anyway very interesting. We have one more question.
Rian Smith is back from Trinidad with this. Is there a Lama school or video playlist created, or will there be a pipeline? Also, demo accounts to learn and so forth.
Yeah. How do the demos work?
So demo accounts is available now. So if you go to lamamix.com, you can download the free trials. And the free trials is for Lama Connect and for Lama Mix.
And how do those trials work?
Those trial work. So basically, Lama Connect is complete functionality up to 8 connections. After 8 connections, you can carry on using it, but then every 10 minutes, it's going to give you 10 seconds of silence. And Lama Mix is basically complete functionality, but again, every 10 minutes, you're going to get 10 seconds of silence until you activate your license. So with regards to training and videos, that's my to-dos for the next few weeks. So please come back to me. If you recognize this background, it's because I'll be stuck here for the next few weeks. So yeah.
That sounds great. We're really excited about your product. So we're really, really glad that you were able to come on.
Thanks.
Thank you very much.
Yeah, thank you so much for your time.
Thanks, guys.
And it's lamamix.com, is that correct?
Lamamix.com, yeah. And there's a free trial, and you can click on it. Give us a few details, and then we'll give you the free software.
Fantastic. Thank you so much. And thank you to the panelists for making this show work. First hour, second hour, both in contributing to the questions, to the answers. We can't do the show without you. Thank you to the producers who asked all these great questions, kept us going. It's a real short show without the producers out there watching the show and asking the questions and keeping this whole thing going. We don't have a plan otherwise. It's not like we have 2 hours to talk. Like we just we'll start talking and then the producers will make it happen. And you did once again. And thank you to the incredible teams that make this all work. As you know, this is not a standard Zoom meeting. We have people from all over the world that make sure, literally there were people from, I think, 3 or 4 continents this morning, putting this thing together this morning to make it all happen. So thanks to the development team that builds the hardware and software that is required to make this happen and supports it. Thanks to the management team that is figuring out who's showing up and when. And thank you to the incredible production team that makes this actually happen every single day. We appreciate your contribution. Today, if we had walked around the Tlaloc Traversal, if we had walked from person to person to answer all these questions, we would have traveled 83,000 miles. And that is 133,000 kilometers. And that is 655 million bananas for scale. All right, let's go ahead and jump into After Hours.